Conditional probabilities. So remember, conditional probabilities means you're not dealing with necessarily the entire data set. You're only dealing with certain ones. So in this example, find the probability of choosing a female given the student has brown eyes. So you're looking at all the brown eyes on the bottom. Where's my brown eyes? So you're looking at this. Brown eyes on the bottom. There's your 409. And out of those brown eyes, how many of them are female? Because that's what we want. We want the female. So there's your 261, which gives you the 63.8%. Find the probability of choosing a student with green eyes if the student is a male. So if the student is a male, says we are only dealing with the male students. So my total is 392, and I want a student with green eyes. So in the males, I look and I find the green eyes. I end up with 31 over 392, which looks like it gives me a 0.079 or 7.9%. So if I want to put that in a sentence, 7.9% of males have green eyes. Right, because we're only talking about males. Number 2, find the probability of choosing a female with blue eyes. Is there an implied condition here? I say yes. Because you're choosing a female who happens to have blue eyes. So the condition would be you're looking at females, probability of choosing a female who has blue eyes. So we're only looking at the female population here. So 431, and the blue eyes would be 105, giving us a 0.244 or 24.4%. Given that a student has blue eyes, okay, so now given blue eyes, so that's this one, was probably the student is female. So now we have 318, 105 over 318, which is 0.33, which is 33%. So how is that different from the last one? Well, the last one was if female, blue eyes. So notice how the denominator is what changed. In this one, it was if blue eyes, female. So they're very, very different because it changes your denominator, which changes your entire piece here. Okay, let's go to smoking, because why not? Okay, so we're looking at this piece here. According to a 2006 European study, the risk of developing lung cancer for a man who never smoked is 0.2%, and the risk for a current male smoker is 15.9%, which is almost 80 times higher. Now, number 1, restate the given probabilities as conditional statements. Because what are the conditions for each group? So if you think about this, okay, so I'm going to run out of room here. The probability of lung cancer if you never smoked is 2%, right? Because it's the whole if you never smoked. That's kind of the conditional piece there. If you never smoked, then this is what you have. The other one would be the probability of lung cancer if currently a smoker is 15.9%. So if you're currently smoking, this is your probability. So that's the condition. Did you smoke? Did you not smoke? Okay, now let's look at number 2. How did researchers find each probability? So how did they do this? Well, they looked at all of the non-smokers. So all non-smokers, and then the numerator was the number of them who have lung cancer. So that's how they found one. And then the other one was they looked at all of the current smokers and the number of people who had lung cancer. And that is how they kind of figured it out. Actually, I should rephrase that. They're looking at males. Male non-smokers, male smokers. That does make a difference. But that's kind of the basic idea of how they found those.